Good morning. Today we take or learn class 10th physics. The name of the lesson is electricity. This is an important video which tell us the relationship between current and potential difference, by which law we make the relationship between current and potential difference. Ohm's law tells us the relationship between current and potential difference. According to Ohm's law, at constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its end. At constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its end. So, if I is the current flowing through a conductor, and V is the potential difference, or you can say that it is a voltage, okay, or voltage across its end, its ends. Then, with the help of Ohm's law, or according to Ohm's law, when there is a conductor, suppose it is a conductor and the current flowing through section A is I, and leaving from section B is again I. The potential difference is V. Okay. So we can say that at constant temperature, I is directly proportional to V. Or you can write V is directly proportional to I. Okay. V equalized to R into I. For removing the sign of proportionality, we introduce a constant. So here the constant should be introduced. That constant is a constant of resistance. Okay. So here we can write where R is a constant. The name of that constant is name of the name of the constant is known as resistance. Okay. In which factor the value of a resistance or constant or Ohm's law constants depend upon. So the value of resistance or constant depend upon nature of conductor. What is the nature of conductor? Okay, the value depends upon. Second, length of conductor. Third, area of cross section. Of conductor. Fourth, temperature of the conductor. The value of resistance depend upon. Next, few important case of potential difference and current. The current is directly proportional to the potential difference applied across the end of a conductor. Where we already know I is directly proportional to V. If I is proportional to the V, okay, then the first case arise. The potential difference across the ends of a conductor is doubled, or if the potential difference of a conductor is doubled, what is the value of current at that time? Okay, if the potential ends of a is doubled. What is the current at that time? If we know that V is directly proportional to I, or you can write if the potential difference is doubled. So it became 2V. Then we know that V is directly proportional to I. Then then if V is 2V, then directly proportionate to I. So current is also became 2. So what is the result at that time? So the result is then current flowing through it is also doubled. Second question arrive in our mind. If the potential difference across the end of a conductor is half, then what happens to the current? Okay, so here we write if potential difference potential difference across ends of a conductor is half, then you know that V is directly proportional to I. If the potential difference is half 1 upon 2V, then if it is became 1 upon 2V, then we know that due to proportionality the current is also became half I. So the result we get at that time current flowing through it is also half. Okay. Next topic, important cases of current and resistance. You know that, or we know that, the current is inversely proportional to resistance. I is inversely proportional to resistance. Then again, few questions arrive in our mind. If the resistance is half, what happens to the current? If the resistance is half, we know that I current is inversely proportional to the resistance, or you can write R is inversely proportional to the 1 upon I. Okay, both are same. It depends on you which quantity or which type of question you have given. If the resistance is half, one upon 2 R, then if resistance is 1 upon 2 R, sorry, 1 upon 2 R, okay, it is inversely proportional to 1 upon 2I, or the current is doubled. From this equation we got that the current is double. So we can write so the current flowing through it is doubled. If the resistance is double, another question arrive in our mind. Then what happens? So if the resistance is doubled, you know that R is inversely proportional to the current I. If the resistance is doubled, it became 2R. Then resistance became 2R is inversely proportional to 2 upon I, or the result is, therefore the current flowing through it is half. Became half at that time. Okay. If this video is helpful to you, then like it, subscribe it, and share it. Thank you.